Welcome to the One Spatial podcast. I'm Bob Chell and I look after products and operations at One Spatial. Seb and I plan to use these podcasts just to share our thoughts and interests, which you'll be able to see have no doubt influenced what we do in work and actually how we do it.
My name's Seb and I'm the CTO, and as Bob mentioned, we're going to touch on quite a few topics from our core principles around data. And from the data right through to techniques available to help people reach their ambitions. So a bit of design, some insights into what we're currently thinking about at One Spatial, even some of the core beliefs that guide a lot of what we do.
So let's try and start at the beginning, Seb. And I know I've always talked a lot at One Spatial about data quality, but if we move away from the sales pitch, what do you think it really means to us?
Yeah, we've worked with around data quality for years and years, and it's a speciality and focus of ours. We always, and when we talk about data quality, because of our background, I guess we often are talking about spatial data, but it also implies and is involved with non-spatial data quality as well. And for some people, it's a topic of interest. For some people, though, it's just a thing they do on the side to make them more effective at what they do. So I mean, what do people mean by data quality? And if you look at typical definitions, it's things like fitness for purpose. That's one definition people often use. And that's really key, because data is about something that represents something in the real world. So it's never perfect, it's never exactly the same as reality. It's not meant to be, it's just an approximation. So fitness for purpose is, well, that's going to depend on what you use it for, because it's never exactly the same as reality. And the purpose can be hard to predict as well. So people know what they're using data for, and they know where data problems cause problems in their how they use the data and operationally what they do with it. But it's often hard to predict how you might be using data tomorrow or next week or next year. So it's trying to predict a bit, how might we be using the data? What can we get the most value of in terms of what the purpose is for that data? So, for example, if you're then taking the data and combining it with other things to find out some new information, then how you combine it with that data, you might have information missing that stops you from combining that data. So trying to predict what those usages are. So that's the purpose. The fitness itself, again, that can be hard to define. It could be, right, well, there's missing data, or there's duplicated data, or it's out of date, or the field values are wrong, it's not well classified. It could be not properly cross-referenced. So essentially, the One Spatial approach is that we are trying to define rules that say, well, how good should my data be? And this is how I want my data to be, because this is how I'm going to use it. And tell me where my data is not like that. And that means by doing that, you can end up measuring the quality of your data, knowing how good or bad it is, and determining what is the highest quality of information available for that task, and is that good enough? And then it's worth clarifying as well, here we're talking about structured data. And an easy way of defining what we mean by structured data is answering the question, if it's spatial data, what is here? So if the answer is, well, this is a building, or this is a water pipe, or an ecology zone, then that's structured data. If the answer is it's red, or it's a height, or I've got a reflection from a sensor of this frequency, well, that's not so much structured data. That's sort of more like information that has metadata, maybe a point cloud or an image. So here we're talking about, and our focus is on the data quality of that structured data that you might have generated from the unstructured data.
I think that's a good point to make, Seb, because there's a lot of structured and unstructured data around at the moment, especially with different ways you might use that data. So good point, where what we're talking about here is the fitness of structured data. It definitely helps us narrow the context of what we're talking about. So you and I have both been around in the industry for a long time, as has One Spatial, and there are plenty of people who've been thinking and talking about this problem, I think. Are you thinking that they're thinking the same thing about the problem in the same way that we do?
Yeah, not always. So yes and no. What we definitely see is that there tend to be two different approaches, or approaches coming from different directions. So you get, there are standards for this, and there are standards bodies, and there are academic institutions that research stuff. So, there's ISO standards 19157 that talks about spatial data quality and talks about categories for completeness. Is there missing data, or logical consistency, or topological consistency, or thematic accuracy? And those, and so you see one from one angle, it's a theoretical and standards-based or academic approach, and then the other example is the other direction is purely pragmatic. I'm trying to do something, I'm not able to achieve it because the data's not quite right. How can I improve it? And you sort of try and meet somewhere in the middle, because you don't want to be based purely on theory or defining ways of working which are just not practical or too expensive for people to do. But if it's a free-for-all and you don't take consideration of the data quality, it's just going to stop you from achieving what you need to do. So you're trying to find a neat standard, and you get the standards bodies will set up, for example, test beds where you have different groups working together trying to achieve that thing, and that helps to bring together the pragmatic reality with the theoretical ideal. One difference in our thinking is there are different ways of measuring it, and in the olden days, or the less effective way, you'd do it manually and you'd subsample the data, and you'd sort of have a look and say, well, I've had a look at 1% of the data and I've found 6 errors, so we can extrapolate that out. But to do it sort of reliably, or not to be unfeasibly expensive, you're just going to need automation for these things. So you can automate it, it's cheaper, you can do it repeatedly, you can measure the quality over time by repeating that, and then you can get an idea of data quality. Is it going up or down?
That makes sense, and I think we've come across that in a number of organizations over the years where the business case for this and this type of approach is definitely there. And as you mentioned, with the different standards and the working groups that we've both also personally been involved in over the last little while, it's definitely established and it's recognized by many people. So what makes the one spatial approach, or what we do, different or more interesting than others?
Well, our focus is on automation via rules, because then you can the people who are focused on defining what the quality is can focus on writing the rules, and then you automatically apply the rules to the data, and it tells you where your data's good or not good, and not good enough. But there are two types of rules which are just read only. They check the data, so they tell you where things aren't good enough, so it gives you a measure of the quality, and also it reports all the problems so that you can then go and worry about it or fix it, or flag up in your results that, by the way, we know this data is not perfect and here's where. And then the other type of rule is something that will change the data, so a rule that can fix it, for example. And what that enables you to do, or the best approach, is not just to fix the data as it comes through your data process, but try and trace back to say, oh, actually, the reason why this data is not perfect is because of X, and let's try and improve that process so it starts off good quality. So it could be, using rules at the point where the data's captured, or if data's ingested from an external source, apply rules as the data's uploaded by those supply chains that are providing the data, to say, well, by the way, I'm not going to take the data in and 3 months later go and have a look and tell you about it, because it's too late. I might set some rules up to say I'm only going to accept this data when it's met these rules, and if it doesn't meet the rules, I'm going to give you a list of the problems that you as a supplier need to fix. So you can use that information not just to make the data better, to make your processes better as well. And so yeah, pushing those fixes down the supply chain is going to be useful. But if you could do that, what you need to do is make sure that the rules are sort of transparent, they're visible and shareable. So it's not just I've got a piece of software that's going to say yes or no. It's that I can define the rules and I can explain to you what the rules are, and I can send you the rules and you can run them yourself, and we can all agree on what the rules are checking, and then it's clear and transparent. So this rules library approach is key, where the rules aren't just embedded in some software or in a user's head. You can have this growing managed version library of rules that you can use to manage all this data at all various points in the life cycle of that data.
Thanks, Seb. So we've definitely got a different way to approach things, and I have seen, more people talking about rules catalogs or libraries that we work on, but also, we are building this that's grounded on what the industry's learned over the years with the standards and the working groups. So the technical side is great, but do you think we are reaching out to enough people to talk about data quality in this perspective? For example, do you end up talking about data quality and data governance in the same sentence, which might confuse people? What do you think about that?
Yeah, well, I mean, so one way of looking at it is this is a pretty boring subject, and I'm too busy doing my day-to-day work, and some people will just pay lip service to it, but not sure what to do with it. But the data governance is often used in the same breath as talking about data quality, and that's taken a wider approach, and it's related to terms like master data management, which is not just here is one thing that I'm going to do in my data that measures if it's good or bad, but it's part of an overall approach. So, for example, the looking at the life cycle of data and things like security and storage and where it comes from and what the provenance is, and that's more than just the quality of the data at snapshot in time, but how that whole data is managed. And then if you look sort of more broadly as well, that master data management approach, which is the data might be correct, but there's another system over there with what should have the same data, and that can help me to determine even more places where the data is not right. Either one is out of date, or one system is managing that bit of the data, and when that updates, I need to propagate that to all the other bits of the system that use similar bits of data, and I can match and merge the data between these different systems. So that's another approach to it. That's more like data stewardship. And so the umbrella term data governance, that's mostly about taking all these things together and applying a strategy that has some benefit. But this is all pointless without some benefit overall. So it could be that we're producing a better output if we're a data provider, but often people who manage data aren't doing it because they sell data or give data to other people. They use it as a way of performing their business. So they might be helping to deliver water to customers or make trains run smoothly, and therefore the data is just a side effect of that. And so the data governance, the way that you get the benefits from that is being able to deliver water more cheaply and efficiently, or safer and more regular trains, for example. So we have customers that we typically work with, but we need to put a lot of effort into getting the message out there to different types of people to realize actually your problem is a data quality problem, or at least we can make your problem easier or make the problem go away by focusing on the data quality. And there are various aspects to that, and we'll talk about some of those in future podcasts.
That makes sense, Seb. It is a big topic for us to get right and cover. I'm definitely sure we'll be covering those in future podcasts. Anything we could tease people with right now?
Okay, so if we look at, if you consider a project, then even a data quality project that's part of an overall data quality program, you want to have a sort of continuous improvement approach. So at the beginning, what you want to do is find out what data you've got, write some rules to measure the current state of the data and use that as a baseline. And then you can use that to determine how far away are you from good enough. And it might be fine, great, my data's good enough for my purposes. But if I then find a new thing I want to do with my data, I can quickly look at that baseline and see if it's good enough. But if it's not, we can work out, well, how can we iterate to make incremental improvements to get closer to a good enough. But it's only once you've measured that and know what those things are, can you have an idea about how far you need to go and how good enough your data is. And we've got some of this we've written down we've got a data quality excellence principles in our little book of spatial data quality, which you can download from the website.
I think that'd be a cool one to talk through as well, Seb, on another podcast. So that's cool though. It's given us a lot of good things to think about. And like you said at the end, I think we've always said it's a good idea to try and chunk up what you're doing. So chunk up the way you solve the problems that you've got. And to kind of summarize, really, quality, what we're saying about that is it is to do with fitness for purpose. But make sure, as you said earlier, you keep an eye on the overall data governance program that you're trying to fit into. So trying to work out how in the future you can be smarter and innovate to make those improvements. So from the One Spatial side, we've definitely got an automate first approach, and it's kind of given that the manual checks are expensive and subjective, especially for structured data. So you should be able to automate some of what you need to do and evolve to, what you see as the future needs for the business. And then to fit in with what you're also saying around the industry standards that are already out there, and make sure that everyone's got something that we're doing, but it's future proof. We're doing it for the right reasons. We're doing it based on lessons we've already learned. We're keeping an eye on the stewardship aspect to what we're doing as well. So everything's documented and people can find all the right information. We talked about libraries of rules or catalogs. So even that part is engaging the right people as well as the right processes. So we're not hiding anything away. Everything's available and can be accessed, which is just the way that a lot of good companies work these days. This is what we do. And then we can use the data and other data sets to find out new things, discover new things, infer data that might be missing, and add even more value and improvements to how we work.
Yeah, absolutely. And that's pretty much what we try and do in all these projects. So the book I mentioned before, the Little Book of Spatial Data Quality, you can, it's worth checking that out. That's on the website. The other thing that's worth doing is, just get in touch with us if you have certain topics you want us to talk about. So we're going to be doing podcasts, blogs, etc. about various topics. So we could be talking about machine learning and spatial data, or master data management, or our engineering approach for rapid prototyping, from POC to production. So any specific topics, then, anyone who's listening, then just please get in touch via the website or LinkedIn, and we can factor those into future podcasts. So yeah, thanks for listening.
Cheers, Seb. We'll have another podcast soon.